All right, so we're just going to pick it up where we left off last time. We were designing this book data structure, this book structure, in order to represent a book and all the data that we want to process from it. Just make sure that the audio is okay here. All right. So we'll continue there. First of all, remember that I've got this vertical alignment here. Again, if you don't want to type everything, you don't want to space everything out, you always have this A style available to you, right? This book.h. And when I reopen it, refresh it, now it's all vertically aligned with that first one right there. Also, it's added some extra indentation up here that I should have had. I was just using two spaces. Two spaces, as long as you're consistent about it, is perfectly fine. So, to continue from there, let's now use this book class or this book structure in our demo. If you want to create a book, you can always did I actually create a book yet? Nope. All right, so here, once I've got all the pieces of data, the title, the author's first name, last name, the year published, and the rating, I actually want to create an instance of this book, right? Book B. That's how you can declare it, and we covered that last time. You can call it book if you want to, or just book B, all right? Or if you actually have a title of the book and you want to name your variable that's fine too. This is just generic book, right? Now, if I wanted to assign these values, set up its title, its first name, last name, year published, and rating, I could do that using the following syntax that we covered last time, the dot operator. So if you want to set the title, the first thing you have to do, though, is set up the memory for it. Then once you've done that, then you can copy it over. Otherwise, it doesn't exist until then. Same thing with the first name. Same thing with the last name. The rating is just a double, so you can just go ahead and set that using the equal sign here, the assignment operator. Right? Again, that gets really, really tedious, which is why we previewed that we're not going to do that. We're going to write a function to take care of this so that we can reuse that function over and over again. I'll call my function a create book. This is called a factory function. Why is it a factory function? Because factories produce products, right? They produce widgets. Here's a widget, here's a widget, here's a widget. We're creating books, and this factory function is going to create this book. It's going to take the title, the author's first name, last name, the year, the rating, and it's going to set all that stuff for us. The return type here is going to be a book star, a book pointer, right? Why is that? Let's go ahead and actually implement this now, right? I'm going to go ahead and touch book.c, right? That will create a book.c file over here that I can then copy that over here, and I can start implementing that, okay? What if I did it this way? What if I just did book B, and then I said return B, right? You can do that, but once again, what is a book? Let's come back to that. A book is and I don't have my Russian dolls, nested dolls here like we did last time, but it's a pointer. That's 8 bytes right there. It's a person, and a person is 2 pointers, so there's another 16 bytes, 24 bytes. Also, it's a date of birth, which is 3 numbers. That's going to be 12 bytes. I don't know what I'm up to here, but last time I think we got up to 50 different bytes. Not that big of a deal, but imagine if this was not just a book, but also the actual text. Char text of book, right? Say that we stored the entire book as a text file or just a big giant string inside this structure. That's no longer 50 bytes. What is that? That's 50 million bytes, right? Now it has a pointer to it, so technically not, but you get the idea. Passing by reference, or passing by value and returning by value, which is what I'm trying, let's get rid of that before I forget. Returning by value, which is what I'm doing here, will copy the entire book on the stack in order to return it. That can be quite expensive, even if it's only 50, 60 bytes. If you're in an embedded system and you're returning 60 bytes or something, you might actually start impacting the return stack there. Right? So we're not going to do that. Instead, we are going to create a book pointer and return that, B. All right. Now, first of all, what is this pointing to? If I just do it like this. Well, let's go back and remind ourselves about pointers. If I just go int star ptr, what is that pointing to right now? Could be anything. Could be dead beef. It could be garbage. It could be null. Right? In any case, many attempt to work with that when it's undefined. You're not going to have a successful time there. Likewise, what is that pointing to? Could be anything. Dead beef, null, whatever. If you're going to create a pointer, you need to make it point to something. So I'm going to call the only thing that we have available to us, or that we've covered, malloc. Right? Now I will go ahead and typecast that. Right? How do I create enough memory for a book? Well, if this were an integer, what would it look like? Int star x, or array, if you want an array, right? And this would be a call to malloc, int star malloc, size of int times, how many of them do you want? 10 of them, say. Okay? So let's use that as a model for how we should call malloc for one book. Well, how many bytes does a book take? You could add them up in your head, or, well, how many bytes does an integer take? Size of int. So what should we do? Size of book. It takes care of that for you. Compilers are dumb, but they can go through and count up a bunch of bytes. Right? Whatever it is, 50, 60. Right? How many books do you want? Create books? No, I'm just creating one of them. So how many do you want? One. Now, math-wise, you don't need to multiply by 1. But I like to put that there simply because it is intentional, right? I am advertising the fact that I am only creating one book here. Right? So that's the style that I use. There we go. Okay, let's get rid of that. All right. Now I have to go about and copy over the title, copy over the author's first name, copy over the author's last name, etc., etc. How do I do title? Well, I do something like this. There. B dot title. We'll come back to that here in a second. Is it always going to be Neuromancer? No, it's going to be this title up here. So title, right? And is it always going to be 11 plus 1? No. What should it be? More generally, strlen of title. Is that it? So, say that I've got a book called Hello, Hello. Is that all I need? Nope. Always, always, always with a string. What? Plus 1 for the null terminating character. There we go. Then I can copy it over. Let me try to compile this. Book.c. All right, there we go. It's not going to work. Well, first of all, okay, fine. I'll bring in string. What else do I need to include here? The standard library, since I just created this. I'm not doing any input or output, but I am doing stuff with strings. Right? And finally, I should include the book header file there. That'll get rid of some of the warnings there, but it doesn't get rid of the error. It's complaining about, oh, sorry. Should be B. All right, let's get rid of that too. There we go. B is a pointer, all right? You can't use the dot operator is what it's telling me. Right? And ignore the rest of it. I'm going to explain it to you in here in a second. So if this were a regular old book, right? Then you can use the direct component selection operator like I just showed in that other example. This is not a book. What is it? It's a book pointer. So if you wanted to do something like this where you're going to B dot title, what do you have to do to that pointer first to make it a regular old variable? In other words, B is a book star, in other words, a pointer to a book. We want to make it into a regular old book, right? In other words, not a pointer, right? So how do I do that to a pointer? Dereference it, and so we would end up doing what? Star B. Then we can use dot title. Okay? There we go. I still need to do it down here. This here as well. Okay, there we go. And this will compile. Come on. 15. Yeah, okay. Wow, good job, compiler. I was hoping that it would just be a warning, but it's not. The problem here is that these have different orders of precedence. So if I use multiplication, A times B plus C, Which one of those things gets evaluated first? Multiplication, then the addition. In other words, it's like this. It is not like this. A times B plus C. Those two things are definitely different. Right? Likewise, the dot operator and the dereferencing operator, they have different orders of precedence. The dot operator is actually higher. Right? So if you need to dereference it and then you can use the dot operator, what do you need to do? Parentheses. Right? I can do that, and I can do that right here. Right? Oops, yeah, that's right. And now this will compile just fine. Right? Man, that's ugly. And they realized that that was ugly. Right? Always putting everything into parentheses so that you can dereference it and then use the dot operator. So they introduced something different. When you have a pointer, you can use this thing instead. Right? B, and then what would you call that instead of the dot operator? An arrow. That's exactly what we call it. It's actually the indirect component selection operator, but what does it look like? It looks like an arrow. So we call it the arrow operator. Right? This can so there we go. We did that's what actually what it was asking. Hey, B is a pointer. Did you mean to use the arrow operator there? Right? Yes, I did. Thank you very much. Right? So change that into an arrow. Okay. Let's go ahead and continue. Right. For the title, let's go ahead and take care of the B publish year is equal to publish year. That's pretty straightforward. B rating is equal to rating. There we go. Those two are pretty straightforward. Oh, sorry. Publish year. There we go. Isn't it? Let's find out. Publish date? Oh, yeah. It's an entire published date. Right? We went the full 9 here and actually defined a date here. So let's go ahead and try to compile it. And, of course, it's going to say publish year. That doesn't make any sense. It's published date, and it's not just one number. It's 3 numbers. So let's figure that out. Right? This one's not straightforward. First of all, I'm getting the published date. Now, what is a published date? Well, it's a date. It's got a year, a month, and a day. But is the published date a pointer? Nope, it's a regular old structure. So do we use the dot operator or do we use the arrow operator? With a regular old structure, we use a dot operator. So, come back over here. Dot year is equal to publish year. Right? What about the month and day? I don't have that data. Right? There's nothing to stop me from creating another create book method or function. Right? Create book with full date or something. Create book with full information on the author or something. Right? In fact, you'll find in a lot of libraries they have a lot of these things. They have just different initialization functions. Okay? I'm going to keep it simple on this one though. So you can see a mixture here. Why do we use the arrow operator on the first one? Because B is a pointer. This is no longer a pointer, so we use a regular old dot operator. So pointer to a structure, arrow operator. Right? And it kind of makes sense too, right? If it's pointing, then you have an arrow to something. If it's not a pointer, then it's period. Right? Okay? What about that first name and last name? First of all, how do I get the author? Well, B is a pointer, so let's get rid of that for a second. What was the author's? How is the author defined? There we go. It's a person, right? And a person has a first name and a last name. So let's set those up now. I'm going to get the person or the author, is what I called it, right? Dot first name, right, is equal to a call to malloc of the length of author name plus 1. Why? Because of the null terminating character. And then we can use strcpy for B author. What? Sorry, what? Thank you. Equals first name, author first name. There we go. Can you see it's kind of getting tedious, right? Repeated code here, repeated code here. Well, let's do one more repeated code. What should I have done instead? Maybe. Yeah, make a deep string copy. And I see some people are RTMing, right? And looking around, they saw that there is this function called strdupe, right? and I think you do have access to it. strdupe is a deep string copy, but only in more recent versions of C, right? So if you're using a very, very recent, and it will work on code post, so if you use it there, you're using the correct one. But 10 years ago, it was only an extension. In fact, I think it might still be an extension technically. I saw that it was added as of the C23 standard, in other words, this year. Right? It's been around for a lot longer than that, but just as a standardization, it's very new. Right? All right, so did I get author last name? All right, I committed no copy pasta sins by copy pasting and then not changing something. Looks like to me. Let's run that. Great. It's still compiling. Now let's go back over to the demo. Right? I don't want to have to create my own books. So what I'll do is I'll say book B is equal to create book of title, author first name, author last name, year published, and rating. There. That's also got me thinking that, well, should I be responsible for printing this stuff out? Or maybe this library that I'm building over here that defines a book and defines all of the functions that interact with a book, maybe it should do it instead. Right? So let's do that now. I'm going to move this print function over here instead. Right? Let's go ahead and call it print book. Right? It's going to return nothing because it's just going to print the book to the standard output. And it's going to take a book, B. There we go. There. It prints it to the standard output. That's also, again, not satisfying. What if we're storing megabytes of data in that book, the entire full text of that book? Now I've got some real trouble here. Right? What if I pass this by value? A copy is placed on top of the stack, leading to a stack overflow. So let's not do that. Let's pass a pointer. Right? That thing over there, 8 bytes, that's it. You're never going to overflow the stack on 8 bytes. Right? Am I going to be making changes to that book? No, I'm just going to be printing it out. If I'm not going to be making changes to this string, what did I do to advertise that fact? I made it into a const. You can do it now that once you've created a type here, once you've created a new a struct, you can use it like any other variable, right? It is now part of the language, or is now part of the language as far as your program is concerned. Right? So, any tricks or tips that you've had before, like using, for example, size of, you can use it here. Right? Const, you can use it here. All right. Oh no, did I erase it? Oh, no, I didn't. Good. All right. I'll just copy paste it here. And that's the formatting I want. Let's go ahead. B dot title, is that correct? No, why? What is B? It's a book star. It is a pointer. So we use a arrow. There we go. All right. Author's last name, I have to get the author, and then dot last name. There we go. I have to get the author, dot first name. And again, why am I using a dot here? Because it's just a regular old structure at that point. You could redesign it if you wanted to only have pointers everywhere, right? I'm not going to go over that overboard like that though. Publish date, was it? Publish date, and then we only have the year, so I'll just go ahead and go with the year here. Gee, year, author last name, first name. Oh, duh. Now I'm doing stuff with IO. So what should I do? IO. There we go. Great. All right. Now over here in demo, I'm going to create the book, and then I'm going to print the book. Printf, or print book B. GCC with book.o and demo.c. And now I've got the same exact program as before. Highest rated book is now 4.6. That was, which book was that again? I don't remember, because we're not keeping track of it. Remember what motivated this, right? If you're going to keep track of the highest rated book, you also have to keep track of the title, the author, and the date, and the year. Now you don't. You can keep track of the highest rated book. Right? Book, best book. There. Now down here, highest rated is equal to rating. What do I call it? Best book? Okay, best book, right, is equal to B. Right? Now at the end, the highest rating is, the book is actually printf, or print book, excuse me, best book. There. CCC. It'll compile. Is it going to run? Let's find out. Right. Yep, there we go. Harry Potter and the Deathly Hallows, 4.62. All right. And I didn't have to rewrite that code up there. All I had to do was call the function that acted on it. Right? What if I wanted to print this to a file instead? I wanted to print all this stuff to a file so that I could store it somewhere. All right. So that means that we're going to need another function, right? Or change that to fprintf. Right? That prints it only to a file. Now we need to take a file in, right? Some sort of a file, right? What if I wanted to print it to a socket in order to send it over the network to another computer so it could process that data? Now I need another one. Now I need another one. Now I need another one. How could I solve this problem for all of those scenarios? What if I had a generic toString method here, or toString function, that took a book and returned a string representation of it? Right? Then I could print it to the standard output. I could print it to a file. I could print it to a string. I could print it to whatever I wanted to print. Right? So let's do that so that we can reuse that function down here instead. All right, I'll use the same formatting. Do we remember how to print to a string? sprintf. So I need a string, of course. Char, foo. I'll just assume that it's over. It's at least 1,000, right? Not foo, but result. Right? Return result, and I will print into result. There we go. Does a warning come up? Nope. Here, let's actually compile book here. Oh, awesome! A warning does come up, even without the wall flag. Right? Even more stuff comes up, but or no, not. I guess not. This is the only thing. So why can't I do it this way? Function returns the address of a local variable. What kind of an array is that? A static array. Can you return static arrays that are allocated on top of the stack? No, because what happens to that stack frame when you return from a function? Goes away. Right? That's what it's warning about right here. Okay. All right. Well, the real problem was down here. So what should you do? Char result is equal to a call to malloc. Char star malloc. Right? How big should it be? 1,000? Right? Times size of char. That's big enough. But it's kind of a waste too, right? You've overestimated the number of characters you need for any book just so that you didn't have to do the math, right? So what would the proper math be here? Well, if you're going to print the title here, then it'd be at least 40, right? Probably strlen of B's title plus strlen of the last name plus, and then also you need to add in the punctuation, right? There's a space there, a comma there, parenthesis. You would need to add up everything, and you'd have to be pretty dang accurate about it. Right? I don't like doing that either. So I'm going to keep it like this. 1,000 is big enough. I just can't return it like that. Right? I'm going to treat this as a temporary buffer, just like you've been treating it in your labs and hacks. Right? It's okay if it's big enough and it's only going to hold this amount, of this amount. Why? I'm not going to fill it up, right? But I am going to reuse it and reuse it. Once I have printed to this temporary string, right? Suppose that it's only 100 bytes now. Now what I can do is copy it into a string that's exactly that size. Char star result is equal to a call to malloc strlen of temp times, or size of, actually I should do it like this, size of char times strlen of temp, what goes at the end? +1, always. Right, there we go. And make sure all the parentheses are there. There we go. And then I can str cpy into result temp. And then I can return the result, right? Did I have to do any adding things up and, oh yeah, I put in a comma there and oh, now I go and change it and I need another comma or something like that? No, right? All I did was print it to this temporary string, created a deep copy of that string, and that's what I end up returning. Cool little trick here, right? All right, great. And by the way, do I need to clean up temp? Should I free up temp? It's a static array, right? It gets popped off the stack along with everything else, right? Do not free the stack, right? That will result in a stack error, stack smashing event, right? Instead of a overflow. All right, now let's use that down here in print book. I'm going to create a string representation of B by calling toString of B. Right. Then instead of printing all this stuff out, I will simply print out the string. In fact, let me take out the endline character up there. There we go. And I'll just put the endline character down here. And I'll print out str. Much simpler. And then return. Be careful. What am I forgetting at the end of this function? Let's think about that for a second. What does toString create? Dynamically allocated array of characters. I create that array. I use that array. I print it out. Am I done with it? Yeah, I'm done with it as far as this function is concerned after I'm done printing it. So if I've got memory that I'm done with, what should I do with it? Free it up. Otherwise, that would have been a memory leak right there. toString. Did I put that in the other file? Nope. Put it there now. There. Come back, document all this later. Right. So GCC, all of this together. Come on, where is it? Book. GCC, everything together, and run it just to make sure that I didn't break anything. Yep, it still runs. Right. Okay. Print book calls toString, and now if I wanted to printf a book, do I have to write any new code? Nope. Just call this method over, this function over here. Right. If I wanted to print it to a socket to send it over the network, just call that function right there. Make sure to clean up after yourself. Right. toString, or better to call this book toString, right? Because what is it? toStringing? It's a book. Change it right there. Okay. All right. Cool. Let's go back over to the demo here. At this point, with only 20 minutes left, let's go ahead and clean up this code now. All right. You know, what I'm doing here is I'd like to separate these things out because I'm doing two things, but I've spaghetti coded this up. What I'm doing is I'm loading up stuff from the CSV file, right? And then along the way, interleaved with that, right, all spaghetti coded up, I'm trying to find the highest rated book. Well, what if I wanted to find the lowest rated book? I would have to add code right here in the middle of everything again. What if I wanted to find all of J.K. Rowling's books or all of Frank Herbert's books, right? I would have to add that code here as well, right? I want to do one thing, then another thing, then another thing. So let's separate this code out so that it's not all interleaved together, right? Let's separate out some of this code here to just load up the data, right? And yeah, there we go. From there to there. Let's define that function first of all. Load book data, CSV data. CSV data. There we go. And we're going to load it up from a file. So const char star file path, right? Just like you're doing in this hack right now, right? And I'll leave it like that for now. All right. So what is this going to return? If I wanted to load up all of the data here, not just one book, but here are all 20 books. how do I return that? Do I just return one book? No. I return an entire array of books. So how do I represent that? How do I represent an array of integers? Int, there's one of them. How do I get more of them? Int star. So, book, book star. Right. Now, wait a second. That looks really familiar. Right. Those two functions have the same return type, a pointer. Right? Don't get confused by that. A pointer to 5 books, an array of books, that's the same thing as a pointer to an array of size 1 book. Right? It doesn't matter how big the array is. 1 book, 5 books, 1,000,000 books. It's going to be the same thing. It's a pointer. Okay? So let's actually implement this now over in the book.c file, or at least get started on it. Right? There. I've already written this code. All I'm going to do is move it over. Right? And fix it, of course. Right? All right, so I don't need the file name anymore because that's being given as part of the input there. Right? All right, buffer 1000, great. I'll read the first line. I know the number of books now. This is a different concern, right? That's the thing that I wanted to separate, so I'll get rid of that. That has nothing to do with loading up books now. Right? For however many books there are in the file, I get that line. If the last line is an end-line character, I chomp it out. I don't need this cruft anymore. I don't need that debugging print statement anymore. I get each one of those tokens, and then I create a book. Great. I don't need to print it because I'm not printing them out anymore. I'm just loading them up. I don't need to check the rating because I'm not finding the highest rated book anymore. After this is all said and done, I close it. Where's my array? Did I create my array yet? Nope. I just create this book and then throw it away. Create this book, throw it away. Create this book and throw it away. Once I have this book, I need to put it somewhere. Okay? So, up here, let's create an array of books. Right. Book, star, result. Or books, if you want to. Right. I like that. It's going to be a call to malloc. Book, star, time, malloc, and size of book. There we go. Be careful. One of the most common errors is to get this wrong. And that will work, but it will give you something like 8 all the time. Why? Because a pointer is always 8 bytes. Make sure that you are getting the correct size of there. Only you ever use size of on types. Int, double, char, and now that we're creating our own types, book, author, date. Right. How many of them do you want? Num books, but do we know that yet? Nope. So what do we have to do first? We have to read that line that tells us how many books there are. There. Now I've got my array. So let's put that book into the array. I've got my for loop here, so all I have to do is say books of I is equal to B. Let's try compiling that. Book.c. Right. Incompatible types on that line. What is the thing on the left-hand side? Books of I is a ... Well, books is a pointer. When you index something, it becomes a regular old variable, right? Just like a char. Char, my string, right? That's a char star. Strings of 0, say. What is that thing right there? That is a char, right? When you index something, it is basically dereferencing it and making it into that one thing. So when I dereference books using this index here, this is a book, right? But B is a ... book star. All right. How do I take B and change it into a, which is a pointer, and change it into a regular old variable so I can put it into an array? One of those two things. Which one is it? It's the asterisk, the dereferencing operator, right? There we go. There's still a problem that we'll take care of here in a moment. Right. Uh-oh. Did you mean booked? Yes, I did mean to book to string. Where did I put that? Oh, no. To string. Oh, okay. I needed to change it down there, too. There we go. There. Now it's fine. Okay. Now, there is still a problem here because there is a memory leak. All right. So, to do check memory leaks here. And why? We'll take care of that later, though. Right. Now, at the end, let's go ahead and return books. There we go. That, by the way, we didn't have that before, but it was compiling without warnings because I wasn't using the wall flag. Always use the wall flag, right? Line is set but not used. You reach the end of a non-void function without a return statement. Oh yeah, I needed to return books. Oh, good question. Does it belong like that? No, then your file never gets closed. All right, there we go. All right, GCC that. All right, don't worry about that. Let's come back over here to demo. Now I can simply call that function. Book, excuse me, star my books, or I'm just going to call it books. That's stupid, right? Is equal to load books CSV data of file name. Awesome. Right. Now I can get rid of this. I can get rid of, well, here, let's retain that because I still need to check to see if the rating, the highest rating here, if the rating of the ith book, so books sub I, oh, here's a good question, dot or arrow, we'll find dot or arrow, we'll come back to that in a second. And then update this, and then I update the best book. Okay, and then I print it out. Right? I've cleaned up all the code. I've separated out the concerns. I've put all of the loading functionality over here in this function, and I can simply just reuse it. Once again, on code reuse, all of your hacks have been designed so that you can get away with a lot of code reuse. For example, if anybody has, hopefully you've started the protein part. That protein program should be no more than 7 lines of code, period. No more than 7 lines of code if you are reusing code properly, right? You need to change is it thionine to uracil or uracil to thionine? Which one is it? Whichever it is. You need to change a U to a T or a T to U. What does that sound like? It's a character. It's a replace char, right? Okay, you need to remove all the white space. That sounds familiar too, right? Oh, you need to split the DNA up into trigrams. That sounds familiar too, right? As long as you're reusing the good code that you've already written and already reusing the code from this hack, again, it should be no more than 7 lines of code, period. Right? Keep that in mind. We're not going to dock you if you rewrite everything, but you're making your life way harder than it needs to be. All right, so load the book CSV data. Highest rated book, there's the best book. Was this a period or was this an arrow here? Well, remember that books is a pointer, but books sub I, that's dereferencing it, making it into a regular old structure. So which one is it? Dot. Right. Dot rating and books sub dot rating. Right? And we update the best book. Let's try that. Yep, GCC this. Oops, get rid of that. Best book. Oh, and then B sub I is what I meant to do. It's still not going to compile though, or maybe it'll compile with a warning. Okay, there we go. Oh, okay, good. A couple of problems here. How many books do I know that I have? I need to check how many books I have. Int book. Well, should I just hard code it to 20 because that's what's in the file? No. So who's responsible for telling me how many books there are? Who knows? Do I know? I'm main right now. Do I know how many books there are? No, because I called this function to load it up for me. So does that function know how many books there are? Yeah, otherwise it wouldn't have been able to create the array. So how can I get this function to tell me, here are the books, but also here's the size of the array? Can I return two things from a function? Nope. So what do? Pass by reference variable. What is it? Numbooks? There we go. It's char int. All right, there we go. All right. So let's open up that. There we go. Right, there we go. That has the exact same signature, right, as your read file lines. Right? Okay. So something very, very similar here to what you're doing right now. And I need to set it. So once I've got oh, darn it. Can I have numbooks and numbooks? No. So let's go with number of books. There we go. And there. Numbooks is equal to number of books. Can I do that? Careful. One of those is a pointer. The others is not. The other one is not. How do I reconcile that? I want to set this pass by reference variable. So if I have a pointer, how do I make it into a regular old variable? Dereference it. Okay. And then use number of books down here. Is that it? Yep. Okay. GCC that. Good. Oops. There's another one. Darn it. Where is it? Number of books. There we go. There. All right. Then GCC everything together. All right. Now we got rid of that one compile error. Right. We still have this one though, right here on line 27. Best book is equal to B sub I. Again, it's a pointer versus a regular old variable incompatibility thing. What is the thing on the right-hand side? Oh, sorry. It's not books. It's not B, it's books. There we go. That's a regular old book. What is the thing on the left-hand side? A pointer. So how do I change a regular old variable into a pointer variable so that I can use it like this? Remember, it's just the opposite. Ampersand. Right. There. All together? Oh, no. Too few. Oh, because I need to. Okay. Number of books. Where is it? I still had it hard-coded to 20. So, good. Yet another opportunity for review here. How do I pass in that variable there? It's a regular old variable, but does load books expect a regular old variable? Nope, it expects a what? Pointer variable. So, how do I change a regular old variable into a pointer variable? Ampersand. That should take care of everything. Books. There we go. We're still all good there. I'm not printing anything out, by the way. If you wanted to, you could. How would we do that? Print book. Right. Books sub I. Again, this is a lot of pointer dereferencing and referencing practice. Book sub I is a regular old book, regular old variable. Does print book expect a regular old book? Nope, it expects a pointer. So how do I change this into a pointer so that it can pass? Ampersand. There we go. There. Now I'm printing everything again. All right. Any questions so far? No. Again, it's a lot of boilerplate stuff, but once you've got the boilerplate in there, you can do some amazing things. For example, what if I wanted the lowest rated book? Right? Do I have to load them up again? Nope, I've got everything into an array. What if I wanted all books by Frank Herbert? Right? I could go through and find all of them and then produce a new array or something to filter them out. We don't have enough time to do that, but we'll probably do that next week at some point. Right? But otherwise, we've got a way of... We've got a definition of all of our stuff. We've got a way to create one book. We've got a way of creating dozens of books, right? An entire array of books. We've got a way of printing something. We've got a way of converting it to a string so that it can be printed. we've got the boilerplate of something that we can then reuse, right? We could do a lot of different data analysis and reporting over here now that we've created this foundation so far. Right? No questions? Homework? Anything? Oh, yeah, go ahead.
Can you change the function heading to include a pass by reference variable in like our assignments?
No, they have to be as given. In the assignments, they have to be as given. Now, that doesn't prevent you from adding whatever functions you want, right? So, for example, I foresee a need to count the number of lines and count the number of characters in a file, right? I'll put that into a function, right? And now I'll do them both at the same time, right? And so I'll return two variables, one num lines, num characters, right? And that's half of the battle right there, right? Or better yet, you know what? Honestly, you could use one function to implement the other, right? If you created, if you got the entire file contents in one big giant string, right? You could go through and then you could tokenize it along n-line characters and create an array based on that, right? So really, you only need one or the other, and then if you use one or the other, you can convert an array into one big giant string, or you can change one big giant string into an array, right? So lots of code reuse. You could cut it down and play code golf. What is the minimum number of lines of code could you write? Right, and again, literally the protein exercise should be like 7-8 lines of code. We don't count not blank lines, but we don't count these as lines of code right here. That's just formatting. Right. So, good luck, and I'll see you on Monday then.